Hey everybody. All right, so let's do example 3. We'll do E, F, G, and H, I think, on this video. So I started saying in the last one, look at the top, we've got a square root. So if that's the case, I know that that can never be negative. So for that one, I'm going to do just a little bit of work. I'm going to say 2x minus 1 has to be greater than or equal to 0. Okay, so I have to deal with the top, and I'm going to come up with some domain restrictions there. So because I'm a good little work shower, I am going to add the 1 to both sides, drop down my 2x, which is greater than or equal to 0. Nope, greater than or equal to 1, divided by 2. So x has to be greater than or equal to 1/2, right? So if I had a number line, I've got 1/2 right here, and then I know, hey, it's going to go, it can include the 1/2 and then greater than, so I'm going to squiggle to the right. Okay, now there's one slight issue. We also have to look at the bottom and say, all right, the bottom can't be 0 either. So we're restricting the domain possibly even more. If I have x squared minus 3x minus 10, I'm going to say, oh, I can factor that. I can factor that into x and x, and I know it's 2 and 5. And then I decide what has to be negative, the 5 or the 2. The 5 has to be negative. So if I'm setting that equal to 0, I know that x can't be negative 2 and x can't be 5. So then I'm going to look back at this graph. See the red part? I said before that x has to be greater than 1/2 for that top to work. Well, but right now I just said that x can't be negative 2, but really, did I already know that? Yeah, that's kind of an extraneous solution that doesn't help us on the bottom. It couldn't be negative 2 anyway, so I don't even worry about that. But then my other place that has an issue, there's going to be a break at 5. I don't know if that's a hole or an asymptote. My guess is an asymptote, but again, we'll learn that next week. So I have this cute little graph here, but that's not really what I'm looking for. I'm looking for it in interval notation. So I look and I start at 1/2 inclusive, and then I can go over. Oh, there I hit 5, and there's something happens at 5. So I give that a parenthesis. Then a union, and I start again at 5, and then it can go on forever and ever. So I close it down at infinity, which really means it's unbounded. So there's my domain, 1/2 inclusive up to 5, and I don't include the 5, union 5 to infinity. So again, something's happening at that 5. Now, if I wanted to go over into my graph, I could click over to decimals, which I graphed before. Oh, hey, look. In my graph, it tells me that I start at 0.5. It doesn't go to the left of that. And then it goes on and on forever. But hey, something that curves down. And something funny happens here at 5. So at 5, there's like this break. And then it starts again. It looks like it's in a different place. But this graphically says, yep, what I have here is good. Right? So let's see what happens in F. The top. Are there any domain restrictions on the top? To which I say, nope. But are there some domain restrictions on the bottom? The answer to that is yes. Now you know that this whole absolute value can never be negative. But I will also submit to you that in this case, it can't be 0 either. Why not? Because you can't have 0 on the bottom. So I'm going to pull that out and I'm going to say, all right, 4 minus 7t has to be just flat out bigger than 0. Can't be equal to 0 either. So I lay out my line. How do I undo 4? I minus 4. So I drop down. I've got negative 7t is greater than negative 4/7. Oops, sorry, 4, negative 4. And then I'm getting ahead of myself. Now to undo that negative 7, I divide by 7. So I get t, and I get positive 4/7. But what happened when I divided by that negative? hey, I've got a flip of the inequality. So what does that look like? That just says t has to be less than 4/7. So how do I write that in interval notation? Well, I start at negative infinity, and that's unbounded, and then I go to 4/7, and I decide what kind of, do I want a parentheses or a bracket? Well, since it can't be 4/7, that would make the bottom 0. I have to open it. So my domain is negative infinity to 4/7 and brackets on both sides. All right, the next one, let's do G. I'm going to look at the bottom and the top. Well, let's start looking at the top. I see an absolute value. What do I know about an absolute value? Can never be negative. Now there's a negative sign in there, but we can work with that in a second. Could it equal 0 in this case? Yes, it could, because it's on the top. So 0 is fine then. So I'm just going to pull it out and say negative x has to be greater than or equal to 0. Now, how do I undo that negative? I can divide by -1. A lot of you would say, well, you just flip the sign. Yes, because I still get 0 over here. But what happens with this inequality? It flips the other way. So I now have, oh gosh, something happened. X is less than or equal to 0. Okay, so now that I've got that, if I just kind of had a little number line, I've got 0 here. So x has to be less than that, so I could bracket it, color to the left. But now let's see, are there any extra domain restrictions on the bottom? Well, I know that the bottom can't be 0. So I would say x squared plus 5 can't be 0. Is there anything that x could be that would make that a negative or a 0 down on the bottom? To which I say, no, because x squared can't give you -5 and have a real solution, right? So this one is somewhat just look at it, think about it. Oh, x could be anything because I square it, so the positive negative isn't an issue. So all I need is that domain restriction from the top. So my domain restriction from the top said it has to be less than or equal to 0, so that, because it was already a negative in there. So unbounded on the bottom, I go infinity to 0 to the 0 count. The answer is yeah, it does. All right, letter H. I had to call Mr. Pouliot on this one because I was getting weird answers and I was trying to figure out why is this not working for me. Well, look at the top. Is there anything x can't be on the top? And the answer is nope, can be anything you want. And then on the bottom, I was like, well, 3 plus 5x squared has to be, greater than or equal to 0. And then I thought, wait a second. X squared, if it's a real number, will that ever be negative? No. So this one, there aren't any exclusions because it's x squared down there. So since there's no exclusions, this one's all real numbers, but in interval notation, I say that negative infinity to positive infinity.